Okay, so this first video is all about the different types of forces. So we're going to go over the basics of kind of just naming forces and kind of where we can give examples of them as well. So it's first noting that forces are essentially a push or a pull. We don't write push or pull, though we give them the names. They are measured in newtons, so that's given with a capital N. So I'd say, for example, a force of 5 newtons or 10 newtons. Okay, so types of force. The first ones I'm going to talk about are our drag forces, okay, also known as our resistive forces. Okay, now essentially what these do is they oppose motion. So we have friction, we've got air resistance, we can also have that resistance within a fluid, so we could call it fluid resistance or water resistance. But essentially, if it's on a solid surface, if I'm moving my hand across my book at the moment, I'm going to be having two solids in contact, so I'm going to be having friction, is what's trying to slow my hand, it's what's trying to oppose the motion of my hand. Okay, the other one then is air resistance. And so, for example, as maybe a car is travelling through, it's going to have friction from the wheels, but also the air is going to be slowing it down. So we also have air resistance, or a plane travelling through the air, or a skydiver falling down. Okay, the one that's opposing their motion is air resistance. Water resistance or fluid resistance, that one comes through anything travelling through a liquid. So, for example, a submarine, a boat, somebody swimming. Okay, the force that's opposing their motion, okay, that's dragging them back, all right, is going to be called water resistance. So we call these our resistive forces or our drag forces. The next one is known as the applied force. Now, essentially, this is your push or your pull. So if I push on the desk, I'm applying a force. If I push a box, I'm applying a force. If I pull a box, I'm applying the force. So it's kind of that force where if you're doing a push or a pull and you can't really think of the name for it, usually it's going to be the applied force there. Thinking about you're applying that force, okay? You're either pulling something or pushing something. Be really careful and not to get that mixed up with tension, okay? Because we also have tension in ropes and things as well. So be really careful with that one there. But essentially, usually your name for the push or pull. The next one is the force that helps to lift things up, okay? And in case of like a plane, okay, if you're taking off or keeps the plane floating in the air, that would be known as lift or upthrust, okay? I usually stick with upthrust, and actually you could call all of these upthrust, it doesn't matter. But sometimes when you hear things in water, so if you have a boat in water, the fact that the boat isn't sinking is because there is a buoyant force, okay? We could still call it upthrust, but in water, we tend to call it buoyant, okay, or shortened to buoyancy. So buoyancy is for the water, and then lift often is associated in air, but we can call them both upthrust. Essentially the force that's helping to move things up or balancing out with what's pulling them down. The next one is to be really careful with, and that is weight. Okay, be really careful. It's not gravity. Okay, we'll do a whole little thing about weight, but essentially it's what's pulling us towards the earth. Okay, so if I'm standing on a surface, okay, the weight is what's pulling me down. Okay, if I'm falling in the air, so like a skydiver, it's what's pulling me down is my own weight. Again, with the boat and the water, what's pulling it down, okay, is weight. So W equals mg. You can have right weight, but remember to not call it gravity. There's another video about this. Again, a plane in the air, what's trying to make the plane fall, again, would be its weight. So it's weight, okay? Be really careful. When we use weight in everyday language, we don't actually mean weight. We mean something called mass. All right, so that's on this side. Let me just turn the pages. And we now have our normal and reaction force, or normal or reaction force. Sometimes you call it normal, some people call it reaction, some people call it the normal reaction. But essentially, this is the force if I'm standing on the ground, I'm not falling through the earth because the earth is also pushing back against me. Okay, so that's known as the normal reaction force. If I push on the desk, my hands don't fall through the desk because there's a normal reaction force pushing against my force. If I push against the wall, okay, I'm applying that force. I don't go through the wall because the wall also pushes back against me with the normal or reaction force. Okay, and it's always perpendicular to the surface. Okay, so for example, on a ramp, if a ball was going down the ramp, okay, the normal force is always going to be at 90 degrees to the surface. So the normal force is 90 degrees to the ramp. Okay, So that's that little one there. The next one is to be really careful with is the difference between a tension and a spring force. I'm going to use my little hair bubbles here to kind of help demonstrate this. So if I stretch my hair bubble out, I'm putting it under tension. Okay, so that's the tension force that is currently being used and held within this hair bubble. If I let it go, it springs back. In that case, that's the spring force. Okay, so spring force is the one that's causing it back to move. Okay, whereas tension is the one that when we're putting it under stress. So in a round, like a wind-up jack-in-a-box, I'm really sorry about my diagram. This is a jack-in-a-box toy. If we wind it up and wind it up and wind it up, okay, that's going to be the tension. And then when we let it open and it springs back, that's the spring force. Okay, so tension and spring, when we're dealing with springs, just be really careful which one are you putting under tension, which one is the springing action. You can also have tension though in lots of other things. So for example, you might have some like tug of war games, pulling on a rope. If you're pulling on that rope, there's going to be tension within there as well. Okay, so often that one can be a little bit more difficult to think about. And then the last one is thrust. And thrust, essentially, I always think of it as like my engine force. Okay, that's just as a little tip there. Okay, so if you've got a car, it's got an engine, the thrust that's making it move forwards, a plane, thrust from the engines that's propelling it forwards. Okay, essentially it's the forward moving force. Okay, so essentially, always think when you've got something with an engine, you've usually got the thrust from the engines that's propelling them forwards there.